So, which is best? So coming back to the basic conclusion was that draw texture is the best. If you want to cover all platforms and get your overall best performance. Again, you got to check. Here's the call you usually make in OpenGL, that you check to see if the extension is present. If not, you're going to fall back and use the standard 1.0 drawing method. Canvas is really good if you can get away with it. You know, if you're not trying to really pump out the sprites. This one will allow you to do a lot of fancy drawing using all the standard high-level SDK stuff like text along a line and stuff that would be difficult to do in OpenGL. And at the bottom here is the URL, so you can go download this app. It's totally open source. Other guys downloaded it and they've started adding their own tests into it. So it's a good starting point just to get familiar with the platform. Okay, now we're moving on to 3D. Where are 3D gamers out there? Okay, so 3D. So again, we developed another application called the height map test. This one is brand new. It hasn't been released on our code site yet. It's coming shortly. This one is pretty cool. What it does is it generates a terrain model here with meshes, and you can control a lot of variants here, and which will allow you to test all different aspects of your hardware. So this is a great one to take and put on, say, the Nexus and on the Droid, and compare how they're going to perform, bring it down to the G1, and see if you can get it running on that. Here are the variants that we have right now. So we support single, multiple tiles. You can create more complex meshes or less. You can tweak the colors. And basically, you can turn all these parameters on and off and kind of tune it to see how, you know, what you want to target your app for. So here are some interesting numbers. Here again is the G1 versus the Nexus 1 test. And the same parameters, we got 2.4 frames per second on the G1. We got 12 frames per second. So we got a 5.1 speed increase when you go to the Nexus 1. And you can see the GPU is much more robust on the Nexus 1. And sometimes with 3D games, the developers will tend to target the high, if they're really pushing the envelope, they'll target the high-end devices, and they'll basically filter their app on wide VGA to kind of make sure they're targeting just those applications. Okay, native code. What is native code? Native code basically lets you go in there and write using C and C++. As you're probably aware, Android is built on top of Linux. So if you're a Linux developer, you'll be totally comfortable at this level. You basically build what they call a shared object file, which in Windows is like a DLL. And when you launch your Java application, it has to be bundled within the Java application. You'll load the DLL into your memory space, and then you'll make JNI calls down to the native code or into the libraries to execute your native code. So when you develop on the native platform, here's a list of the standard libraries that we provide currently as of today. So you can access to all the most of the libc functions that you're used to, string copy. You can even do file I/O and network activities. You can do libm, the map, JNI, libz for compression. Log will let you log just like you do from the SDK. And then of course OpenGL-ES. And then we also supply some basic stubs to get you started with C++. Native development isn't easy. Right now it's at its early stages. There's a lot more coming with it in the future. Right now the debugging is done through logging, which isn't too bad considering most people are just doing porting, so they're not actually developing from scratch on this platform. Hopefully most of the bugs have been wrung out of it. The other challenge, as Roman mentioned, was that you can't get direct input from the native level, or you can't play sound once you're inside the native level. So the trick is you make JNI calls either from your host Java app to push events down, or you can play sound from the native level through a JNI call back up to your Java app with a message to play a sound. Okay, now here's the big question. When should you consider doing native development? Well, the most obvious answer to that is guys who have already got a huge code base. They've already spent a year or 2 years developing a game engine, hundreds of thousands of lines. There's no way they want to go over and start from scratch again. This is the #1 reason we have guys doing native development. And a lot of guys have done that. They brought their engine over, and we have a lot of high-performance 3D games using this method. Other situations would be high-performance graphics. You're doing some kind of powerful graphics engine, and you want to get that squeeze every CPU cycle out. Same with physics simulations. Again, certain games have very intense physics as well. Maybe you're managing some huge database type of application. That might make sense to go use the native development kit. In the end, we really discourage people from doing it because it's going to result in you compiling ARM-specific, right now, libraries. And so if new CPUs come out on new devices, it gets more complicated to support that. We allow multiple SOs to support that type of thing, but generally the SDK is being developed and tuned so much that over time we're going to see less and less of advantage going down to native. That the SDK level, the Java Dalvik engine is getting better and better and better. That the distinction will be smaller and smaller. The future. So we're going to continue supporting the native library. There's, again, a big demand by a certain segment of our users. And we're going to look into adding direct input, playing sound. Now, one thing we've seen out there is people, they get anxious to start using all the cool features that are there that aren't authorized. So there's ways to access some of the libraries that we haven't made public yet. And when you do that, basically there's no contract there, and they can change at any release. So what happens is those libraries change. The next time the OS is rolled out, their apps don't work anymore. So we really discourage that. Thanks. And we're also going to continue to improve OpenGL. Improve debugging, so less logging and actually stepping eventually. And then there's no plan to really make native a full-blown application framework by itself. So it's always going to be more an assisted framework to the main SDK. One of the things we've been asked a lot is games can get big. A lot of people have tons of resources. We want to make everybody aware that right today there's a 25 megabyte limit to what you can upload to the market. So there's ways around it. One of the ways around it is to just separate out your resources into a separate downloadable. Upload your core app. Once your core app is installed on the phone, then have it make a connection up to the server and download the separate resources onto the SD card. So that's one of the tricks for people who have massive apps. We're going to skip the demo today. We're running out of time. But I wanted to get a survey again. Who here has an Android phone? So what is that, about 40%? Yeah, I think at Google we feel that's way too low a percentage. So we'd like to get that percentage up, and we want you guys to go out and write really fantastic apps. And like Roman said, I think we want you to start coding as soon as you leave here. So I think to get that kicked off, we're going to give you all a Nexus 1 today. And I also want to make you aware that if you prefer like a Droid, if you're in the US and want a CDMA phone or the one with the keyboard, when you come up here you have the option to get a Droid as well. Just let them know. So the way we like to do it is to have everybody come up to the middle, starting in the front rows first. You can go up this side. Yeah, stay in the middle, and this side over here. When you're done, kind of file out to the sides. And I think we're ready. Okay, thank you.